This image captures the exact moment a hard seed transforms into a fluffy cloud of foam. This infographic shows a cross-section of an intact kernel, revealing the specific layers required for that reaction. The outermost layer is the pericarp, or hull, a tough, highly resilient, moisture-proofed shell. Directly inside sits the endosperm, a dense, rigid matrix of hard starch. This microscopic view of the starch granules reveals the critical component hidden within that matrix, tightly trapped pockets of liquid water, making up exactly 13.5% of the kernel's weight. Structurally, a popcorn kernel is a perfectly sealed biological pressure vessel, carrying all the raw materials needed for an explosion and waiting only for a catalyst. This diagram shows what happens when we introduce that catalyst. As a heat source is applied, the external environment rises to exactly 347 degrees Fahrenheit. Looking at the left side of this illustration, the intense heat converts the microscopic pockets of trapped liquid water into expanding steam. As the right side shows, this steam violently expands but remains trapped by the resilient pericarp wall, causing the internal pressure to spike. With continuous heat applied, this pressure gauge illustrates how the force inside the kernel escalates dramatically. The structural integrity of the hull is the single point of failure in this system. If the pericarp cracks early, the steam escapes, the pressure drops, and the pop becomes impossible. This map of the kernel's interior highlights the dense, hard starch matrix that is simultaneously enduring this extreme internal environment. Under the combination of intense heat and extreme steam pressure, the normally hard starch melts down into a thick, molten gel. Looking at the pressure gauge, the internal environment heats up until reaching 135 psi, the absolute limit the hull can withstand. At this exact millisecond, right as the hull reaches its breaking point, consider the state of that highly pressurized, gooey molten gel. In this final moment before the pop, the kernel has transformed into a microscopic bomb of superheated, pressurized liquid starch, primed for explosive decompression. As the hull shatters, this illustration captures the climax. At exactly 135 psi, the pericarp shatters, causing an instantaneous and violent drop in pressure. The sudden absence of that confining pressure allows the molten starch gel to rapidly expand outward in all directions. Looking at the final step of the transition sequence, the expanding gel flash cools in the outside air, solidifying instantly into a spongy foam. This visual summarizes the 4 non-negotiable variables required for this reaction: exactly 13.5% moisture, a strong structural hull, 135 psi of steam pressure, and the crucial starch phase transition. The creation of popcorn relies on precise structural biology and perfect heat application to trigger a flawless phase change. It is an exact thermodynamic science.